AP Calculus AB, Unit 9, Day 6, Office Hours. These are the answers. You can pause the video and check them real quick. I'm not going to leave them here very long. So mean value theorem now for any kind of function. Check your answers if you haven't yet. Okay. Comes on the back. I'll show you working setups for 12 and 13. Okay, let's try these problems out. So, first problem is find F average. Just find the average. So, this is our new formula. We're going to find the average. We think of it as the area under the original curve. And if we smooth it out, it's in a rectangle. We divide by the base of the rectangle, get the height, and that's F average. So that's what we're going to do. So on this first one, F average is going to be 1 over 6 minus 3, 3 to 6 of x squared dx. And so we're going to get 1/3. It's going to be x cubed over 3, 3 to 6. So it's going to be 1/3. We're going to plug 6 in. It's going to be 72 minus 3, and it's going to be 9. So that's going to be 1/3 of 63. And that will give us an F average of 21. So that's how we do it. Okay, next one. F average equals 1 over 7 minus 1, 1 to 7 of x cubed plus 1 dx. Okay, so let's see. We're going to get 1/6 x to the 4th over 4 plus x, 1 to 7. Okay. All right. Ooh, that's going to be a big number. That's 7 and 4 is 49, 7, 49, 81 carry the 8, 36, 44, 0, 36 carry the 3 to 16 is 19, 1, 10 carry the 1, 14, 24 on 1. That's a big number. Plus 7, and then we've got to plug 1 in, 1/4 minus, plus 1. Then we've got to distribute. So let's see. That's going to be 2400 over 4 plus 6. This goes in nicely, right? Isn't it 600? So it's going to be 1/6 of 606. So that's going to be 101 for F average. All right, next one. F average equals 1 over pi minus pi over 4. Pi over 4 to pi of sine x dx. So that's going to be 1 over 3 pi over 4. Integer is going to be negative cosine. So that's going to be 4 over 3 pi. And it's going to be, I guess we could go to this next line. 4 over 3 pi. Negative cosine of pi minus negative cosine of pi over 4. So that's going to be plus plus. That's going to be, that's a negative 1, that's going to be positive 1. So 4 4 let's see, 4 over 3 pi is positive 1 plus root 2 over 2. So if we, and then we would distribute this, but we could give this guy at least common denominator, I guess. Let's just think of like how we can simplify this. We could give this least common denominator. So that'd be 8 plus 4 root 2 over 6 pi. But then we could divide 2 out of everything. 4 plus 2 root 2 over 3 pi. That's your F average. Okay. Next one, find all C's guaranteed by the mean-value theorem. So they're not explicitly asking to find F average, but you have to in order to find the C value. So we can start with that. F average equals 1 over 5 minus 1, 1 to 5, x squared plus 5 dx. And so that would be 1/4 x cubed over 3 plus 5x, 1 to 5. And then plug 5 in, is going to be 125 over 3 plus 25 minus 1/3 plus 5. Okay, so we're going to get, that's going to be 124 over 3 plus 20. And 3 does not go into that. So I guess we could do least common denominator. So it's going to be 1/4 times 184 over 3. And that would be 92, 46, that would be 46 over 3. So that's your F average. And then we're going to set the original function equal to F average and solve. So we're going to subtract 5, which is going to give you 31/3, and then we're going to take square root of both sides, plus or minus. Got to see plus or minus. But we only want values between or on the endpoints 1 to 5. That's about square root of 10. That's about 3 point something. So the positive one is going to work. So C equals positive square root of 31 over 3. That's a place where the original function's value equals the average function. Okay, next one. F average equals 1 over pi minus 0, 0 to pi, of 2 sine x plus 1 dx. It's going to be 1 over pi. The antiderivative is -2 cosine x plus x. And this is going to be -2 cosine pi plus pi minus -2 cosine 0 plus 0. So cosine is -1 and cosine 0 is 1. So it's going to be positive 2 plus 2 is 4 plus pi. So our value is 4 plus pi over pi. That's our F average. So we got to find that first. And then we're going to take the original function, f of x equals 2 sine x plus 1, and set it equal to F average. Now, we're definitely going to need a calculator. Well, no, we could probably write this without a calculator. You would subtract 1 from both sides, right? And that'd be pi over pi, so it would be 2 sine x equals 4 over pi. So then sine x equals 2 over pi. And alpha would equal the inverse of this. And it would be quadrants 1 and quadrants 2, right? And so the quadrant 1 answer, we're only looking for values between 0 and pi, which would be just the first quadrant 1 and quadrant 2 answers. Quadrant 1 answer would be alpha, which is be straight out alpha, which we could write this as the exact answer. And then quadrant 2 would be pi minus alpha. So these are the exact answers without a calculator. With a calculator, it would be 0.690 and 2.451. So it was a little fun at the end, fun trig. Okay, number 6, f average equals 1 over 3 minus 0, 0 to 3, 4 minus x squared dx, 1 over 3, 4x minus x cubed over 3, 0 to 3, 1 over 3, plug 3 in, we're going to get 12 minus 9 minus 0 minus 0. So it's going to be 1/3 of 3, which is 1. So f average is 1. So then we're going to take the original function and set it equal to f average. So x squared equals 3, square root of both sides, plus or minus. We only want values between 0 and 3, which should be the positive square root of 3. Okay, now let's apply this to motion. Average position, S average, and here's your position function. So we could say 1 over 4 minus 0, integral of S. Same idea, it's just another function. So we would get 1 over 4, t to the 4th over 4, minus 3t cubed over 3, 0 to 4. Plug 4 in, I'm going to get 64 minus 64 minus 0 minus 0. Whoa. So that's going to be 1/4 of 0. So S average is 0. That's possible. Interesting. Average velocity. So there's two ways we could do this. We could use our new approach. We could say, all right, V average equals 1 over 6 minus 0, integrate 0 to 6 of velocity. So velocity is 3t squared minus 6t. 3t squared minus 6t. So we have to take the derivative to get the velocity equation. But next thing we're going to do is undo the derivative, right? So it's a little extra work to do more extra work. So it's going to be 216 minus 108 minus 0 minus 0. It's going to be 1/6 of 108. So that's going to be 18 for your average velocity. Now the alternative approach, which I would take, is say, oh, average velocity, that's a derivative. Let's just do S6 minus S0 over 6 minus 0 right away, which is essentially what we're doing here. We did a lot of extra work to get there. And S6 is 216 minus 216. And S0 is 0 minus 0. And so you get 0 over 6 is 0. Oh, shoot. I messed up. I'm going too fast. Confusing is the last problem. Okay, so you plug 6 in. This should be a 108. 108. So then we get 108 over 6 is 18. So that was a lot faster. But only good if you don't go too fast and make mistakes. Average acceleration, we could say, all right, 1 over 3 minus 0, integral of 0 to 3 of the acceleration function, which is 6t minus 6. So we're going to take the derivative to find the acceleration function so that we can then integrate it, which means we're going to undo the derivative. So it seems like we're doing extra work to undo it. So if we plug 3 in here, it's going to be 27 minus 18 minus 0 minus 0. So it's going to be 1/3 of 9 is 3. So that's your average acceleration. But I think it would probably be better, since we already have the velocity, to just say, oh, well, that's going to be velocity at 3 minus velocity at 0 over 3 minus 0. Mean value theorem for derivatives. Acceleration is the slope of the velocity function. So let's just find the slope of the secant line between the endpoints. And then, so plug 3 in here, and you get 9 minus 18. You plug 0, you get 0 minus 0. So you get 27, actually, minus 18. So we get a 9 over 3 is 3. Same answer. So, I mean, it's up to you, but if it is a derivative, I'd use that special derivative rule that we learned a while ago. Back to kind of some review problems, or at least new versions of problems we've done before with fundamental theorem of calculus, part 1. Okay, so these first ones, these are all like the same kind of problem, but with a slight different twist. And you get problems like this on your next test for sure. So we, this is a little confusing because capital F is the antiderivative of little f. So f prime is little f. So this is the same thing as f prime. That's just the way they write it, which I find personally a little confusing. But fundamental theorem of calculus says, oh, well, if we integrate f prime, we're going to get f. And, you know, if we have 2 and we want 6, then I put 2 and 6 here, which is perfect because they just gave us that. And you get f of 6 minus f of 2. And this is what we want, so we're just going to solve for f of 6, which means we're going to have f of 2 plus the integral of 2 to 6 of f prime of x dx, which is little f of x, by the way. And so we have these values. F of 2 is 10. The integral is 20. So f of 6, it's got to be 30. This is fundamental theorem of calculus part 1. Right? Fundamental theorem of calculus. If you integrate the derivative, you get the original function. A to b, plug the limits in. Fundamental theorem of calculus part 1. Okay, next one. Same idea. This one's written a little more friendly, I think. So 2 to 8 f prime x dx. It's going to give you f of 8 minus f of 2, which you've been given as 7 minus 3, which is 4. Okay, fundamental theorem of calculus part 1. Next one. I'm giving you information with the derivative, but this time as a graph of the derivative. Same idea though. We're going to start with the same exact approach. We're going to write the same stuff down. We say, okay, well, we have 2, we want 7. If we integrate the derivative, we get the original function, plug limits in. This is what we're hoping to get. So f of 7, solve for it, equals f of 2 plus the integral of 2 to 7 of f prime of x dx. Okay, so you have f of 2 is 18, and now we just got to find the area and its curve from 2 to 7. Now, I personally would just do that as a single trapezoid. The bases are 5 and 3, and the height is 4. So as a trapezoid, it'd be average of the bases, 3 plus 5 over 2 times the height would give you 16. Or, if you don't feel comfortable with that, but you want to do extra work, you do a rectangle and a triangle. So it'd be 3 times 4 is 12, 1/2 base times height, 1/2 base is 2, height is 4, So that's going to be 4. Together it makes 16. But the big idea here is that it's exactly the same as the last problem. That wasn't a graph. Okay, here's another graph of the derivative. So we're going to say, okay, well, let's integrate the derivative. Go 2 to 6 as we want to. We know 6. So we're going to get f of 6 minus f of 2. So f of 2, if you solve for it, you add over here, subtract this over here, you get f of 6 minus the integral 2 to 6 of f prime of x dx. So then f of 2 equals f of 6, they give us 100. This is going to be the area from 2 to 6. Now, however you want to break it up, we could break up a trapezoid, a rectangle. You could do a triangle, a rectangle, another rectangle. But I'm going to go with trapezoid. So the trapezoid is average of the bases, add the bases, divide by 2 times the height, which is 2. So that's going to be 8. And this one is just rectangle. 2 times 6 is 12. And so that's going to be 20. So f of 2 equals 80. Show your work, show your setups. We're going to have some of these in the next test, and people are going to just mess up the areas, and I'm not even going to know why, because I can't tell from their work. These are exactly the same idea. I'm giving the derivative. I'm giving another value. I want another value. Now, in the past, we say, oh, let's integrate that by hand, find plus c from this. But 1, you can't. Simply, you can't. 2, even if you could, you don't want to, because you're being allowed to use graphic calculators. It's going to be way faster, even in something you could do by hand. So we're going to start it the same way I did the others. If I integrate f prime, I'm going to get f. I'm going to go 3 to 12. Use the one I know. Use the one I'm trying to find. Smallest, biggest. Write it out. This is what we're trying to find. So f of 12 equals f of 3 plus the integral 3 to 12 of f prime of x dx. So f of 3 is 10. And we do 3 to 12 of e to the x sine x, which you guys can't integrate by hand yet. I'll teach you how next year in Calc BC, or someone else will teach you how. But who cares? You have a calculator. It's the I would rather do it in here. So I'm going to do this all as one line. So I'm going to say, all right, 10 plus math 9 e to the x sine x, better be in radian mode, comma x, comma 3, comma 12. Thinking. Still way faster than me doing it by hand. And there's the answer. Perfect. Negative 112, 336.903. If you're going to truncate, which I always recommend, like, you can't really mess up truncating, just ignore the next decimal. But if you round, you could round wrong. This time, that'd be the rounded answer. This is a setup, though. This is the work you got to show. Okay, next one. Same idea. If we integrate f prime of x dx from 1 to 8, we get f of 8 minus f of 1. I want f of 1, so I'm going to add over here and subtract this. So f of 1 equals f of 8 minus the integral 1 to 8 of f prime of x dx. So f of 8 is 2. And I'm going to integrate 1 to 8 of x squared natural log of x dx. I'm going to do this all on my calculator. It's going to be super fast and accurate. So let's see. We're going to do 2 minus math 9 x squared natural log of x, close parentheses, and natural log, comma x, comma 1, comma 8. Done. So negative 296.113 truncated Or if you really like doing extra work and the possibility of messing up, you could round. And that would be the right answer if you round. That's it. That's it for this assignment. So